students, welcome to today's maths class, and today we'll do rational numbers. Our learning objectives are equivalent rational numbers, standard form of the rational number, properties of operation of rational number, representation of rational numbers on number line, and rational numbers between two rational numbers. So in the previous class we have already learned about the natural numbers, whole numbers, integers and the fractions. We have also studied over the various operations on the rational number. In this chapter, we will study about the positive and the negative rational numbers, comparison and the lowest form of the rational number. Properties of the rational numbers. We will also learn to represent the rational number on the number line and find out the rational numbers between two rational numbers. So first is rational number. A rational number is a number that can be represented in the form of p by q, where p and q both are integers and q is not equals to 0. In other words, the rational number is also the quotient of two integers p and q in the form of p by q, where q is not equals to 0. For example, each of the number 3 by 7, minus 2 upon 13, 8 upon minus 17 and minus 5 upon minus 12 is a rational number. Positive rational number. A rational number is said to be the positive if its numerator and denominator both are positive or both are negative. For example, 5 by 6, both numerator and denominator are positive. Minus 15 upon minus 19, both are negative. So these are positive rational number. Negative rational numbers. A rational number is said to be the negative if its numerator or denominator are the opposite sign. One is positive and other is negative. For example, minus 2 by 5, minus 3 by 7 and all these, they are negative rational numbers. Know it. Every natural number, whole number and integer is the rational number because 8 can be written as 8 by 1. p by q की form में लिख सकते हैं. Minus 11 can be written as minus 11 upon 1. So these are rational number. Next is equivalent rational numbers. If p by q is a rational number and n is non-zero integer, then p by q equals to p into n upon q into n. For example, minus 3 by 7, so here what we have done? We have multiplied both the numerator and denominator by the same non-zero number. So they are equivalent rational numbers. Clear? So minus 3 by 7, minus 6 upon 14, minus 9 upon 14, minus 12 upon 14. All these are rational number, that is equivalent rational number. If p by q is a rational number and n is the common divisor of p and q, then p by q equals to p divided by n upon q divided by n. So here we have divided the rational number, both the numerator and denominator, by the same number. Standard form of a rational number. A rational number p by q is said to be in the standard form if p and q are integers having no common divisor other than 1. And q is positive. अगर denominator positive है and p and q में 1 के अलावा कोई common factor नहीं है, then they are in standard form. For example, express 32 upon minus 56 in standard form. So first we'll make the denominator positive. So what we'll do? We can also write it minus 32 upon 56. Now we'll divide both the numerator and denominator by their HCF, and that is 8. So we'll get minus 4 by 7. That is the standard form of the given rational number. Next is comparison of the rational numbers. There are two methods of the comparison of rational number. One is cross multiplication method and other is by making like terms. So first is cross multiplication method. Let p upon q and r upon s be two rational numbers. Then if p into s, that is greater than r upon s, then p by q is greater than r upon s. If p and s का जो product है, that is less than r into q, then p by q is less than r upon s. If p into s, that is equals to r into q, then p upon q, that is equals to r upon s. Now we'll take an example here. We have to compare 4 upon minus 5 and minus 8 upon 9. So here we'll use the cross multiplication method. So first 4 upon minus 5, that is not the standard form. So first we'll convert into standard form. So that is minus 4 upon 5. Now we'll cross multiply the numerator of the first rational number multiply with the denominator of the second rational number, and the numerator of the second rational number multiplied by the denominator of the first rational number. So minus 4 into 9. that is minus 36, and 5 into minus 8, that is minus 40. As we know, minus 36 is greater than minus 40, so we can say 4 by minus 5, that is greater than minus 8 upon 9. Next, by making like terms. So, step 1. Express each rational number with the positive denominator. Take the LCM of the denominator of all the rational number. Express each of the given rational number with the LCM of common denominator. The number having greater numerator is greater. We will take an example here. Compare minus 7 upon 15 and 11 upon minus 20. So, here they are not same, they are not having the same denominator. So, first by taking LCM, we will make the denominator same. But before that, this has the negative denominator. So, first we will convert into standard form. So, that is equals to minus 11 upon 20. Now, we will take the LCM of 15 and 20. So, LCM, that is equals to 60. Now, we will make the denominator same. So, 60 divided by 15, that is 4. So, multiply both the numerator and denominator by 4. So, that is equals to minus 28 upon 60, and it will become minus 33 upon 60. Now, we can compare the numerator because denominator are same here. As we know, minus 28 is greater than minus 33. So, we can say minus 28 upon 60 is greater than minus 33 upon 60, or we can say minus 7 upon 15 is greater than 11 upon minus 20. Next is absolute value of rational numbers. The absolute value of rational number is numerical value regardless of its sign. The absolute value of p by q and minus p by q is same because हम sign को consider नहीं करते, only numerical value को लेते हैं. So, this is the sign for absolute value. So, absolute value of p by q, that is p by q, minus p by q की भी p by q. 7 upon 15, absolute value is 7 upon 15, minus 5 upon 21, absolute value is 5 upon 21. Next is know it. The absolute value of every rational number other than 0 is positive. The absolute value of 0 is 0 itself. Next is exercise 1.1. Express each of the following rational number in standard form. So, first is minus 12 upon 30. So, here the denominator is already positive. So, what we will do? We will divide it by their HCF. So, minus 2 by 5, that is the standard form. Clear? Practice all the questions of this exercise. Next is properties of operation on rational numbers. Commutative, associative and distributive properties of operation on the rational numbers are almost same as for the integer, whole numbers and the natural number, but they are different closure property. Closure property: rational numbers are closed under the operation of addition, subtraction, multiplication, but not closed under division. So, 7 by 8 addition, you will get a rational number. Here in subtraction, again you will get a rational number. If you add 2 rational numbers, you get a rational number. If you subtract 2 rational numbers, get a rational number. If you multiply 2 rational numbers, you will get a rational number. We can add 0 to a rational number or subtract 0 from a rational number to get the same rational number. We can multiply the rational number by 0 to get the 0 itself, the rational number. But if we divide a rational number by a 0, for example 5 divided by 0, that is not defined. So, rational numbers are not closed under division. However, the collection of all the rational numbers other than 0 are closed under division. We know that the whole number and the natural number are not closed under subtraction. The following tables show the comparison. Rational number closed under addition, yes; subtraction, yes; multiplication, yes; division, no. Integer, they are closed under addition, subtraction, multiplication, but not in division. Whole number, addition, yes; subtraction, no; multiplication, yes; and division, no. Natural number, addition, yes; subtraction, no; multiplication, yes; and division, no. Next property is commutative property. Addition and multiplication are commutative for a rational number and integer, whole numbers and natural numbers. The change in the order of two rational numbers does not change their sum or the product. अगर हम 2 रैशनल नंबर्स को ऐड करें या मल्टीप्लाई करें, वी कैन ऐड एंड मल्टीप्लाई इन एनी ऑर्डर, their sum and the product will not change. Like here, minus 2 by 5 plus 1 by 4, so we'll get minus 3 by 20. Now we'll change the order, again we'll get minus 3 by 20. Same in the multiplication, minus 2 by 5 into 1 by 4, that is minus 2 upon 20. Now we'll change the order, again we'll get minus 2 by 20 as a product. Clear? But the change in order of 2 rational numbers change their difference or the quotient. Therefore, subtraction and division are not commutative for rational number. Like 2 by 3 minus 5 by 4. So, we'll get minus 7 upon 12. Now, if we change the order, 5 by 4 minus 2 by 3. So, we'll get 7 by 12. See, here the differences change. Same in the division also. If we change the order, the quotient will be changed. Next is associative property. Addition and multiplication are associative for the rational number, an integer, whole number and natural number. Means we can group them in any way, the sum will remain same. Like minus 1 by 2, here first we'll add these two numbers and then जो sum आया उसमें हमने minus 1 by 2 को add किया. So we'll get minus 59 upon 42. Now we change the grouping, again we'll get the same sum, minus 59 upon 42, and for multiplication also. So that is the associative property. The rational number are closed under associative property for addition and multiplication. Inclusion of single negative term in the bracket is not always necessary, but the change in the grouping of 3 rational numbers change their difference or the quotient. Therefore, subtraction and division are not associative for the rational number. If you see here, if we change the grouping, the difference will change. Here 19 upon 30 and here minus 11 upon 30. Same with the division. So, the division and subtractions are not associative for the rational number. Next, use of commutative and associative property. These properties make the calculation easier in many situations. We'll take an example here. Find 4 by 5 plus minus 7 upon 13 plus minus 6 upon 25 plus 9 upon 26. Solution. To do the above sum, we have to take the LCM of 5, 13, 25 and 26. The denominator 5 and 25 have the common factors and 13 and 26 also have the common factors, which will make the finding LCM easier. Using the commutative and associative property, we change the order and the grouping of term and changing their sum. So, we can also write it like this: 4 by 5 plus minus 6 upon 25 plus minus 7 upon 13 plus 9 upon 26. Now, we will take the LCM 5 and 25, that is 25. So, that is equals to 20 minus 6. Here the LCM is 26. So, minus 14 upon plus 9. So, 14 upon 25 plus minus 5 upon 26. Now, we will take the LCM, that is 650. Solve करेंगे 239 upon 650. That is our answer. Next is additive identity for rational number. Like the natural numbers, whole number and integer, 0 is the additive identity for the rational number. When we add 0 to a rational number, we will get the rational number itself. Minus 3 by 5, if we add 0 to it, we will get minus 3 by 5. Next is additive inverse of a rational number. As for the natural number, the whole number and integer, negative or additive inverse of a rational number is the rational number which added to it gives 0. Minus 3 by 4 plus 3 by 4, that gives you 0. So, minus 3 by 4 is the negative or additive inverse of 3 by 4 and 3 by 4 is the negative or additive inverse of minus 3 by 4. Next is multiplicative identity. For any rational number p by q, we have p by q into 1, that is equals to 1 into p by q, that is p by q. So, 1 is called the multiplicative identity for the rational number. For example, 22 upon 53 multiplied by 1 gives you 22 upon 53. Next is reciprocal of multiplicative inverse. As for the natural number, whole numbers and integer, the reciprocal or the multiplicative inverse of the rational number and the rational number which when multiplied with it gives 1. Minus 4 by 5 multiplied by 5, 1 minus 4, that gives you 1. So minus 4 by 5 is the reciprocal or the multiplicative inverse of 5 upon minus 4, and 5 upon minus 4, that is the reciprocal or multiplicative inverse of minus 4 upon 5. Know it. 0 has no reciprocal. The number 1 and minus 1 are their own reciprocal. The reciprocal of the positive rational number is positive. Next, we will take an example here. Is 7 by 8 the multiplicative inverse of minus 1 1 by 7? Why or why not? So minus 1 1 by 7 को हम मिक्स फ्रैक्शन है इम्प्रॉपर में चेंज करेंगे, सो दैट इज इक्वल्स टू माइनस 8 अपॉन 7. सो 7 by 8 को if you multiply by minus 8 by 7 we'll get minus 1. So we can say the 7 upon 8 is not the multiplicative inverse of minus 1 1 upon 7, because their product of 7 by 8 and minus 1 1 upon 7 is not 1. Next, distributive property of multiplication over addition. If minus 2 by 3, 3 upon 4 and minus 5 upon 6 are the three rational number. So minus 2 upon 3 multiplied by 3 upon 4 plus minus 5 by 6. So how will solve it? पहले हम इन दोनों को ऐड करेंगे एंड जो भी हमारा सम आएगा विल मल्टीप्लाई बाय minus 2 by 3. So we'll get 1 by 18. Clear? So here we have used property minus 2 by 3 को हम पहले 3 by 4 से मल्टीप्लाई करेंगे and then minus 2 by 3 multiplied by minus 5 by 6. So we'll get minus 1 by 2 and 5 by 9. Therefore हमने यहाँ पे प्रॉपर्टी यूज की है और इन दोनों का जो आएगा सम उसको ऐड कर देंगे. So that is equals to 1 by 18. So this is how we can use the distributive property of multiplication over addition. Clear? Next is exercise 1.2. Using the property, find minus 4 by 5 into 3 by 7 into 15 upon 16 into minus 14 upon 9. So here we know we can multiply two or more rational number in any order. So here we will use property minus 4 by 5 multiplied by 15 upon 16, because we can reduce into lowest form. 15 is the multiple of 5 and 16 is the multiple of 4. Next, 3 by 7 into minus 14 upon 9. 5 3s are 15, minus 1, 4. Here 3 1s are 3, 3 3s are 9, 7 1s are 7, minus 2. So that is equals to minus 3 upon 4 multiply by minus 2 upon 3. Minus 2 upon 3. So that is equals to minus 1 and 2. So minus 1 multiplied by minus 1, that is equals to 1 upon 2. That is our answer. Next is representation of rational number on number line. We can represent integer on the number line leaving unit distance between two consecutive integers. There is no integer between two consecutive integers, but we can insert rational number between two consecutive integers. The denominator of the rational number indicate the number equal parts into which any unit has been divided, where the numerator indicate as how many of these parts are to be taken into the consideration. To show 7 upon 4 on the number line, we find between which two consecutive integer does it lie. 7 upon 4, that is equals to 1 3 by 4. So it lies between 1 and 2. So we divide the unit distance between 1 and 2 into 4 equal part. जो भी denominator होगा उसके according. Denominator is 4 here. So 4 equal part में divide करेंगे. So between 1 and 2 के बीच में होगा. Clear? So 1 and 2 के बीच में 4 equal part करेंगे. 5 by 4, 6 by 4 and this is the 7 by 4. Clear? Then 8 by 4 will represent 2. Like this will represent the number. Next, rational number between two rational numbers. Let us find how many rational numbers are there between 2 by 5 and 1 by 2. So first we convert 2 by 5 and 1 by 2 rational number with the same denominator. So for that we will take the LCM. So that is equals to 4 by 10 and 5 by 10. Now the denominator are same. So we may think that there is no rational number between 2 by 5 and 1 by 2. That is 4 by 10 and 5 by 10 as they seen consecutive. But we can also write 4 by 10 as 40 by 100. Both numerator and denominator को 10 से multiply करेंगे. And 5 by 10 we can write 50 upon 100. Now the number 41 upon 100, 42 upon 100, 43 upon 100 till 49 upon 100 are all between 4 by 10 and 5 by 10. The number of these rational number is 9. Also 4 by 10 can be expressed as 400 upon 1000 and 5 by 10 can be represented as 500 upon 1000. Now we see that the rational number 401 upon 1000, 402 upon 1000 till 499 upon 1000 are between 4 by 10 and 5 by 10. The number of these rational number is 99. Like this we can write many rational number between two rational number. Thus we get the countless rational number between any two given rational number. Now we'll take an example here. Find the 10th rational number between minus 2 upon 5 and 1 by 2. So first we'll convert minus 2 by 5 and 1 by 2 in the rational number with the same denominator. So first denominator same करेंगे, minus 4 by 10 and 5 by 10. So we can see minus 3 by 10, minus 2 by 10, minus 1 by 10, 0 by 10, 1 by 2, 2 by 10, 3 by 10 and 4 by 10. That are the 8 rational number between minus 2 upon 5 and 1 by 2. But we need 10 rational number between minus 2 by 5 and 1 by 2. So we'll multiply the numerator and denominator by 2. So we'll get minus 8 upon 20 and 10 by 20. Now we have the 17 rational number between minus 8 by 20 and 10 by 20. So we can write any 10. इनमें से हम कोई भी 10 ले सकते हैं. 0 by 20 can be written as 0 only. The above procedure does not work everywhere. To get the exact number of rational number desired in between two given rational number. Next, use of the idea of the mean to find the rational number between any two given rational number. We will take an example here. Find three rational number between 1 by 4 and 1 by 2. So first we find the mean of the given rational number. So 1 by 4 and 1 by 2. So add करके 2 से divide करेंगे, so we'll get mean, that is 3 by 8. Now mean of 1 by 4 and 3 by 8. So that is equals to 5 by 16. Now 3 by 8 and 1 by 2, that is 7 by 16. Now we can find this 5 by 16, 3 by 8 and 7 by 16 are the three rational number between 1 by 4 and 1 by 2. We can proceed in the same way to find the more and more rational numbers between two given numbers. We can show them on the number line. There can be many more such rational numbers. Next is exercise 1.3. Represent each of the rational numbers by the point on the number line. First is 4 by 5. So this is the number line 0, 1, 2, like this. 4 by 5, denominator is 5. 5 by 5 will represent 1. So the number, the rational number will lie between 0 and 1. So 5 equal part 1, 2, 3, 4, 5. So this is 1 by 5, 2 by 5, 3 by 5 and this is 4 by 5. So this point that will represent 4 by 5 and this 5 by 5, that is 1. Clear? This is how we will represent a rational number on number line. Next is summary. A rational number is a number that can be expressed as p by q, where p and q both are integer and q is not equals to 0. If p by q is a rational number and n is non-zero integer, then p by q that is equals to p into n upon q into n. If p by q is a rational number and n is common divisor of both p and q, then p by q that is equals to p divided by n upon q divided by n. A rational number p by q is said to be the standard form if p and q are the integer having no common divisor other than 1 and q is positive. If p by q and r upon s are two rational numbers, then p by q will be greater than r upon s if p into s is greater than r into q. P by q is less than r upon s if p into s that is less than r into q. P by q that is equals to r upon s if p into s that is equals to r into q. The absolute value of the rational number is numerical value regardless of sign. Rational numbers are closed under the operation of addition, subtraction and multiplication, but not closed under division. The additive identity for the rational number is 0. The additive inverse of the rational number a upon b is minus a upon b and vice versa. The multiplicative identity for the rational number is 1. Rational numbers can be represented on the number line. There is infinite number of rational numbers between any two rational numbers. Next is multiple choice questions. Take the correct option. The product of two rational numbers is always a rational number. So C is the correct option here. So here we end the chapter. I hope you understand it well. Now to practice it.